Hello everyone, this is Akash. Welcomes you all into the third episode of my LinkedIn initiative entitled as VLSIpedia. So in this series, I'm gonna make your basic VLSI concepts crystal clear in a very simpler way. So let's start today's video. Today's video is all about the body effect. So what do you mean by body effect or the explained body effect? It is a most favorite question of every MNC interview. Like student find some difficulty or feel complex for these concepts, but don't worry, in next 5 minutes I'm gonna explain it in a very simpler manner. So let's start. So firstly, this is the n channel enhancement type MOSFET. So I have made some little changes in this diagram. So what I have done is that the SiO2 layer, we know that this particular there is a SiO2 layer which isolates this gate terminal from this main body, and I have not shown this particular SiO2 layer. This is the first thing, and you can see the diodes here. So you'll ask what are these particular diodes. So as we know, the source and the drain are heavily doped into this enhancement type MOSFETs, and body is lightly doped. So I am representing it with the P minus, and source and drain are represented by the N plus. So basically we know that when we combine this P and N type of the material, there's a diode forms. So that's why I am showing here diode here and diode here. So these are the some little changes I have made for this better understanding. So what I'm gonna do here, like first I will apply 0 volt, like I will ground all the terminals, source, drain and body. For this time, let's ignore this gate terminal. So I have grounded all these 3 terminals. So what is happening, like voltage of source with respect to body, that is a VSB, is 0. Like we know that the VSB is equals to source voltage minus body voltage. So effectively the VSB is equals to 0, and as there is a diode formation, we can see here the depletion region, and as you know the depletion is due to this particular diode. But now I'm gonna make the change is that I will apply some positive voltage to the source and drain, like some anything positive voltage, let's say 1 volt, 2 volt. So due to this particular voltage, and again I'm keeping this body same as it is. So what is happening here, as this source voltage becomes non-zero, the voltage of source with respect to body, that is a VSB, again becomes non-zero. This is again VSB is equals to source voltage minus body voltage. This particular voltage becomes non-zero. So what is happening, so I am showing this diode diagram again. As I am connecting the non-zero voltage to source, this negative terminal is connecting to this some positive voltage, say 1 volt or 2 volt, and this positive terminal of this diode, this body is grounded, so it is 0. So here some positive volt and here it is the 0 volt. Hence this particular diode is getting reverse bias, and as we know, when the diode is get reverse bias, the depletion width increases. So that's the reason you can see here the depletion, like here I am showing this white area as a depletion width, and you can see here this depletion width is getting increased. So what's actually happened in the MOSFET? So here I am shown this particular channel. Now I am considering this gate terminal, and suppose I have applied this particular gate voltage, which is slightly less than that of the threshold voltage. As we know, threshold voltage, it is the minimum gate voltage required to turn on this particular MOSFET. So at this, say VTH is equals to say 1 volt, and I have applied this gate terminal as a 1 volt, and channel is just about to create. The channel has been not create complete, the creation of this channel has been not completed, it's about to complete, and this all negative charges has been accumulated at this particular source drain, and this current is about to flow. But what's happening here, as this particular source to body voltage is non-zero, the depletion width is getting increased, and this depletion width forces this particular electrons, due to which the recombination occurs, and the strength of this channel, this is the number of this electrons in this particular channel gets reduced, due to which there is the possibility that the channel is not created. Like at this particular 1 volt of this threshold voltage, the ordinary MOSFET is getting on, but due to this particular non-zero source to body voltage, this channel may not get created. For this we require some extra gate voltage for this turning on this particular MOSFET. So ultimately the turn on voltage of this MOSFET is getting increased. That is, the threshold voltage is increasing, and that's the effect is called as the body effect. So if we're gonna define this particular body effect, is that the variation into this source to body voltage results into this increase into this threshold voltage, which results into some extra voltage required for this gate terminal for a turning on this MOSFET. It's called as the body effect. So some mathematical part I am showing here, like this is a particular mathematical equation for this VTH, that is the threshold voltage is equals to VTN 0, that is this threshold voltage when this particular VSB is 0, this is source to body voltage is 0. As we can calculate that the when source to body voltage is 0, then this particular entire term will get 0. Like gamma represents the fabrication process parameter and phi f represents the work function or the Fermi potential. So when the VSB is equals to 0, this entire term is getting 0 and we get the normal threshold voltage. But if the VSB it is the non-zero, then this entire term is getting added to this particular VTH, and which results into the increase into the threshold voltage, which is not required. So this particular thing is called as this body effect. So what are the methods to avoid this particular body effect is that the connect this first method is to connect the source and body to the same potential. Like this I will connect this both source and body to say 1 volt or 2 volts, so that the resultant source to body voltage will be 0. But due to some thermal conditions or this electrons and the holes movement, there may be the possibility that this source voltages or this body voltage get altered, and again there will be the VSB voltage generated. So what is the optimum solution? Optimum solution is that to short this source and body terminal so that VSB will be 0 for sure. That is, if we short the two terminals, then the effective voltage will be 0, and that's the reason when we draw the symbol we short this particular body terminal and this source terminal. So this is particular, it is the optimum solution is that to short this body source and body terminal. That's why the body effect will be totally gets avoided. So that's it for today. I hope your concept of this body effect has been cleared totally. Still, if you have any doubts, you can write into the comment section. I will answer them. And if you find something interesting here, don't forget to hit the like button. You can connect with me from this LinkedIn and this mail. Thanks. So that's it for today. Thank you for the listening, and I'll see you in the next Sunday.